Welcome to my YouTube channel once again. In this video, we are going to discuss about Fibonacci series or Fibonacci numbers. Alright, so years back when I was very young, I read some, this Sloka from a book called Bhagavad Gita. Bhagavad Gita is kind of a book. It is kind of a teaching to, Arjuna from Lord Krishna. This is kind of a Hindu mythology. Okay, so there is a Sloka in there. Sloka, it is like in the chapter 9 and 10th sloka. Okay, it says that under my guidance, nature means Prakriti, this world, gives birth to all moving and non-moving beings. So moving being is like people like us, humans. Okay, non-moving is kind of a trees. Okay, you don't see trees walking around. Okay, so and for this reason the universe revolves, O Arjuna. So the movement of the human being and not so movement of trees, what this sloka says is that is the reason for universe revolving. It's kind of a action oriented universe. Everything revolves, everything is kind of a moving, even though the earth is actually revolves and rotates. So many things happen, even we don't feel it, we don't see it, but still the movement or universe is expanding. So many things are happening without or with or without our knowledge. All right, now after going to Fibonacci series and reading about them, then we know that okay, how nature, under my guidance, nature does it, but how does it nature do? How does it know that to use mathematics or physics to grow? All right, so to understand how nature uses the Fibonacci numbers or series, we need to understand what is Fibonacci number. Okay, so one more thing is that it is something called ekam anekam. That means that one becomes many. First one becomes two, and then two becomes three, so on and so forth. So that is actually that Fibonacci series. So first take any two numbers like 1 and 1. Take 1, add 1 to it, it becomes 2. Then again take 1 plus 2, that is 3. 2 plus 3, 5. 3 plus 5, 8, so on and so forth. So if the number is just two previous Fibonacci numbers, initially 1 plus 1, 2. And then you can actually build the Fibonacci numbers, all the Fibonacci numbers. All right, so how does nature know, how does nature apply this one? For example, I see that so many things like there are 5 petals in a shoe flower, or I actually counted number of petals in a rose, that is 55, and also number of seeds in papaya, that is around 610. Okay, so the petals or leaves, they may fall off because of air or whatever, but seeds generally, if they are in the fruit, okay, they don't. So you can actually count the number of seeds in papaya. All right, so if the number is sum of two previous numbers, 2 is equal to 1 plus 1, then again like this, those are called Fibonacci numbers. All right, then if you see 1 plus 1, 2, 3, 5, right? So there is something called 2, 3, 5. 2, 3, 5 actually are the first primes. If you talk about 2, we talked about prime numbers. All right, so 2 is the first prime number, and that is also only even prime number. And then, of course, 2 and 1 are Fibonacci numbers. So 2 plus 1 is equal to 3 becomes second prime number. Then again, take 4. 4 is kind of a not 2 plus 2, that is not prime number, that is even number. So no other even number other than 2 are prime. So is a prime. So what that means is that we have only 2 as only even number, and then 2 plus 3. Then next, from 3 onwards, there are only odd primes. So 2 plus 3 is 5, that is also prime number. Then again, 3 plus 5, 8. Two odd numbers result in even number. So that's not a prime. Then again, 8 plus 5 is 13. That is even. That is a prime number. So there are primes in the Fibonacci series as well, but we are the only the primes. First primes are 2, 3, 5. All right. So how does nature know to use the Fibonacci numbers to grow? For example, number of petals in a rose, if you see, there might be 55. All right. So again, seeds in papaya, or petals in shoe flower. All right. So this sloka, whatever I read 30 years back, I'm not sure, but yeah. And then when I read this, when I translate it, nature uses Fibonacci numbers in creating flowers. That means the number of petals, seeds in any fruit, trunk, branches, stems, leaves in any tree. If you see any tree, right, it first becomes one trunk, and then it becomes two, then two becomes three, so on and so forth. And also the golden ratio to design any spiral structure, galaxies, tornadoes, seashells. So what is golden ratio? From the Fibonacci series, this is the golden ratio. That is, if you take, let us say, 21 by 13, or 34 by 21, or 55 by 34. So as we grow in number, if you go higher Fibonacci numbers, the result is almost like 1.618. It settles there. Of course, initially the ratio is like 2 by 1 is 2, 3 by 2 is 1.5, then 5 by 3 is 1.6. But ultimately, when it reaches to higher numbers, the ratio settles down to 1.618. So what is the golden number? What is the golden ratio? Is that the solution to this equation, x square is equal to 1 plus x. Okay, when x square is 1 plus x square is minus x, 1 plus 1, x is equal to 1 plus root 5 by 2. That is 1.618. All right, so how this and this are related is that you take any of the, okay, so for example, you take 1, okay, then 1 plus 1, you take 2, this becomes 2. Then again, this is kind of a, all right, so the idea is that this is the higher Fibonacci number. Let us take, this is 34, then this is 21, then there is a square here which is 13. So kind of, the structure, the whatever that spiral structure, when you draw a line, when you connect this line to this one, this becomes a spiral structure. This spiral structure you can also see in human ear or baby in a womb. So it looks like the nature uses, for spiral structures, it uses the golden ratio. All right, and also Fibonacci numbers, by the way. So golden ratio is indirectly is kind of a ratio successive numbers, Fibonacci numbers. All right. All right. Now the question comes that how does nature know to use this? Okay. So the only explanation so far is that there is some higher intelligence which is guiding this nature to use. This is Fibonacci numbers probably, is our invention. And of course, Fibonacci is a mathematician who invented this. All right. And today happened to be Fibonacci day. For example, you have, today is what? 1123. All right, 1123 is kind of a, today is November 23rd. That is, one of my younger mathematician friends who actually told me that today is the Fibonacci day. So I tried to see whether I can make this video on this day. All right. Now, apart from this golden ratio, apart from this, you know, Fibonacci numbers, number of petals and all, if we concentrate on first Fibonacci primes, first primes are actually which are Fibonacci 235. So in my previous video, we discussed about prime numbers and then, Goldberg conjecture as well. So Goldberg conjecture says that every even number is sum of two primes, even from 4. So let us take 4 is equal to 2 plus 2, 6 is equal to 3 plus 3, so on and so forth, right? So 8 is equal to what? 8 is equal to 5 plus 3. Alright, so whatever the even numbers in Fibonacci series are also kind of a sum of two primes. Now there is one more conjecture, weak conjecture Goldberg. Every odd number is also sum of 3 primes. What that means is that just given 1, 2, 3, 5. Alright, just given 2, 3, 5, you can actually construct a number line without using 1. This is also a discovery by one of my mathematical genius friends. Okay, so give me 2, 3, 5, then I can construct entire number line just by using Goldberg conjecture. I don't use 1. So the secret of anything, there are some proofs which are dependent upon 2, 3, 5. So Fibonacci, first Fibonacci primes are also key to maybe that unlock the secrets, and also it becomes like ekam and ekam, 1 becomes 2, 2 becomes 3 and all. So this is kind of a philosophical kind of stuff. But here when we come here, when this translates to kind of a mathematics, golden ratio, or this one, then we can see whether we can understand all this. Okay, so even human ear, right? Human ear is actually kind of it actually uses golden ratio, probably, yes. And then you take any paper, A4, okay. So you see that this is kind of a breadth, and then it is almost like 1.6 ratio. You take any credit card or debit card or any card, the ratio is length to breadth is 1.6, 1 to 1.6. All right, and also you take any book, for example, you take in this book. Okay, this is a book called Principia Mathematica by Alfred, not Whitehead, and Bertrand Russell. Okay, so they tried to prove that 1 plus 1 equal to 2. So there is a whole volume of, there are so many other stuff there, but one of the proofs, they try to prove that 1 plus 1 equal to 2 using logic. Okay, so that is also kind of a mystery. We take it for granted that 1 plus 1 equal to 2. All right, so even this book is kind of a golden ratio book. All right, so, and it looks like the nature uses the most optimized structures. All right, so that means that nature has some intelligence. That intelligence is actually given by higher intelligence. All right, so in the next video probably we can discuss about, there might be relation between the golden ratio and gravity. Okay, so till then, have a great time. Thank you.